So, welcome you all to this new section, and in this section, we are going to analyze the vibration in singular degree of freedom. So, in the first lecture, we are going to see the vibration in undamped system. So, so that is we will learn about undamped free vibrations. Undamped free vibrations. So, what does undamped here means? So basically, undamped means uh, that is damping, uh, damping. That is the resistance. That is the resistance to relative motion. That is the resistance to relative motion is absent. And here the free vibration means the reason behind the reason behind the motion is absent. The reason behind the motion is absent. Now let's uncover a few more steps. So in case of undamped vibration, there is no loss of energy. So there is no loss of energy. So which means that total energy of the system is equal to constant, which also means that amplitude of vibration is constant in nature. So you can see the following plot. So you can observe the following plot somewhat like this. So here this is y-axis represents displacement, and the x-axis represents time here. Okay, so let me first erase this thing. Okay, so this is the x-axis represents time here. Now let's make some base point here. So in case of undamped vibration, the amplitude doesn't vary. That is, the x will not change this thing. So it will look something like this. So here, it has constant x displacement. Like this. So let's define another term here. So another term is the equilibrium position. Let me erase this thing first. Okay, so now let's talk about the equilibrium position. So this means that the mean position, so the equilibrium position is the mean position about which the vibratory system will oscillate. So this is the definition of equilibrium position here. So now let's talk about the method of analyzing. How we are going to analyze this system. So this is the method of analysis. So just consider there is a pendulum mounted in wall, something like that. So this is a pendulum mounted on some point here, and it will oscillate, something like this. It will go here, then come here, then it will go there, then come here, then go there, then comes here. So this is the nature of then again comes here to the mean position. So this is the nature of oscillation of the simple pendulum. So actually there are three methods to solve this type of questions. So the first method is the Newton method, that is the Undamped's principle. So that is, first is the Newton method. We can call it D'Alembert's principle. So here it means that the external force applied is equal to the inertial force here, that is Fi. So we can see that the summation of F external minus or plus, we can say, minus F of I, this is minus sign, equal to 0. So this is the method of solving Newton method or by D'Alembert's principle. Now the second method is of solving this type of question is the energy method. So how we can solve that? We are going to differentiate the total energy of the system with respect to time. That is total energy of the system. That is differentiation of total energy of the system is equal to 0. So this is the second method of solving, that is by the energy method. And the third method to solve the given problem is by using Rayleigh's method. So the third type is Rayleigh's method. So Rayleigh method, let's plot some graph so that you can understand. So okay. So let's plot some graph here. So let's first plot the kinetic energy for this thing. So there are three positions. So first one is extreme position, mean position, then extreme position. So let me write it first. Let me plot first. So for kinetic energy, graph looks something like this, and for potential energy, the graph looks something like this. So this is the extreme position. This point is extreme position. This is the mean position, and this is also an extreme position. So you can see that at this point the kinetic energy is maximum, and at this point also the potential energy is maximum, and also at this point the potential energy is maximum. So we can from this graph we can observe that so from this graph we can easily observe that the maximum kinetic energy of the system is equal to the maximum potential energy of the system. So according to the Rayleigh's method, the maximum kinetic energy of the system should be equal to the maximum potential energy of the system. So this is the whole thing. So there are some keep in mind stuffs that you should remember. So let me erase this thing first. Okay, so few keep in mind stuff you should know that in single degree of freedom systems, the Rayleigh method gives the exact answer for natural frequency, but in higher degree of freedom systems, the natural frequency obtained by Rayleigh method is slightly higher than the actual value. So this is the main takeaway from this lecture. So in the next lecture we will discuss some cases regarding undamped free vibrations. So for now you can wind up. Thank you.